Hi class, it's Miss Vella again. I hope you're not sick of hearing my voice already. Let's try one last one together, and I picked the hardest one. So it says, in a man, optic atrophy, a type of blindness due to a defective optic nerve, is controlled by a sex-linked recessive gene. So that's important. It's a sex-linked recessive gene. Aniridia, a type of blindness due to the absence of an iris, is controlled by a dominant autosomal. So it's not a sex-linked gene. A woman who is blind from optic atrophy marries a man who is blind from aniridia, whose father was not blind. What types of children can they have? Okay, so this is a lot more complicated. Let's talk about first optic atrophy. Okay. So this is a sex-linked. Because it's a sex-linked, I need to have a genotype for females. It's sex-linked recessive. So that means I can have this, this, or this. And who's the only one that's blind? This last one, because it's recessive. For males, I can only have two options. And the one that is blind is the one that has the lowercase b. Okay, the next one, aniridia. Let me do it in a different color. Aniridia. Do I have to use X and Y chromosomes? Do I have to do for male and female? No, because it is a autosomal. So the word autosomal means that it's on chromosomes 1 to 22, not on our sex-linked chromosome. So we can have three options as well. We can have capital A, so we can have, what's this called again? Homozygous dominant. We can have heterozygous, or we can have heterozygous recessive. Now, it says that it is a dominant gene. So who is going to be blind out of these three genotypes? Which phenotype will be blind out of these three genotypes? This one's going to be blind, and this one will be blind. Okay, now for the harder part. A woman who is blind from optic atrophy. So let's look at optic atrophy, and let's highlight. Which one is she? I'm looking at my females, and the only way she can be blind is if she has this genotype, both lowercase v. And then it says, marries a man who is blind from aniridia, whose father was not blind. So let's see, which one is he going to be? Because his father was not blind, what that means is that he's going to have one recessive allele and one dominant allele. Okay, so if I'm looking at the female, she is going to be lowercase a, because she doesn't suffer from an aniridia, and she is going to have both lowercase b's for optic atrophy, because that is how she became blind. For the male, we know he is just a carrier. He is not homozygous dominant because his father wasn't blind. I'll do a little pedigree here. So because we know that he has at least one capital A. And so we have the mother and we have the father, okay? And it says that his father could see. He wasn't blind. The only way his father can see, because it is a dominant trait, is if he was homozygous recessive. So that means he inherited one of the recessive alleles from his father. So that's how I'm able to tell right away that he is heterozygous. Now, he does not suffer from optic atrophy, so I know that he has this dominant allele and he has the Y chromosome. Okay, so now is the time where let's write out, I don't know what your previous teacher asked you to do, but I want you to write out the gametes. So if you look at this, if you look at all the possible combinations, she has only one possible type of gamete, where she has the recessive trait, or the recessive allele for aniridia, and she has the recessive allele for optic, optic atrophy. He's a little bit more complicated. He has the chance, so it's like FOIL, or your distributive property in math, where you have to write each case. So I can have you know what, I'm going to do the X's first, just because I like that way better. Sorry, I'm confusing myself. Okay, so what I did was I looked at these two alleles, okay? So X with capital A and X with lowercase a. And now I'm going to look at the Y allele. So Y with capital A and Y with lowercase a. So we're going to have this. So you might be saying, well, why did I do that? It's an extra step. Because now your Punnett square is a lot more easier. We can arrange it so that it's only a 1 by 4. Why? Because there's only one type of gamete that the female can have, and there's 4 types of gametes that the males can have. So let's write it out. Okay. And can you fill in the correct genotypes? Let's look back. So now we have our Punnett square done. Let's look back, and it's asking, what types of children can they have? So let's label it. The first, I'm going to label it 1, 2, 3, 4. So number 1 is that. So this is aniridia. Aniridia, and then normal optic atrophy. Number 2, no aniridia, and then normal optic atrophy. 3. Let's look at number 3. This is a heterozygous. Are they going to have aniridia? Yes, because it's a dominant trait. So aniridia. And what about optic atrophy? It's going to have optic atrophy. And number 4 is no aniridia. And then, did I do that correctly? Yes, because she only has one case. And then the male is going to have optic atrophy. Now, did you hear what I just said? The male. So let's label, is it going to be a son or a daughter? Number 1, is that a son or a daughter? It's a daughter, 2 X chromosomes. Number 2 is a daughter, 2 X chromosomes. Number 3, a son, X and Y. Number 4, a son, X and Y. So these are the 4 different cases of children that they are able to have. I hope you found this helpful. Please feel free to ask questions in the Google chat. I'll make sure that everybody is able to speak to me through that, but I'm always here to help.